but do you think so? You, Jeff, and Joshua, right? Like both of you won the Turing award together, and you have different opinions about it, right? And Jeff says like he's regrets, and Joshua works on safety, and you trying to push it forward. And do you think you will get to some level of intelligence that you will say, oh, this become too dangerous, we need to work more on the safety side?
I mean, you have to do it right. I'm going to use another example, jet engines. I find this astonishing that you can fly halfway around the world on a 2-engine airplane in complete safety. And I really say halfway around the world, like it's a 17-hour flight. Can fly direct from New York to Singapore, right, on an Airbus 350. It's astonishing. And when you look at a jet engine, the turbofan, it should not work, right? I mean, there is no metal that can stand the type of temperature that takes place there. And the kind of like efforts when you have like a huge turbine, like, rotating at 2000 RPM, or I don't know what speed, like the force that puts on it is just insane. It's hundreds of tons. So it should not be possible. Yet those things are incredibly reliable. So what I'm saying is you can't, build something like a turbojet. The first time you build it, it's not going to be safe. It's going to run for 10 minutes and then blow up. Okay. And it's not going to be fuel efficient, and it's, etc. It's not going to be reliable. But, as you make progress in engineering and materials, etc., there's so much, economic motivation to make this good that, eventually it's going to be the type of reliability we see today. The same is going to be true for AI. We're going to start making systems that, have agency, can plan, can reason, have world models, blah, blah, blah. But they're going to have the power of maybe a cat brain, right? Which is about 100 times smaller than a human brain. And then we're going to put guardrails in them to prevent them from doing, taking actions that are obviously dangerous or something. And you can do this at a very low level. Like if you have, I don't know, a domestic robot, right? So one example that Stuart Russell, for example, have used is to say, well, if you have a robot, a domestic robot, and you ask it to fetch you coffee, and someone is standing in front of the coffee machine, if the system wants to fulfill its goal, it's going to have to, either assassinate or smash the person in front of the coffee machine to get access to the coffee machine. And obviously, you don't want that to happen. It's like the paperclip maximization. It's kind of a ridiculous example because it's super easy to fix this, right? You put some guardrail that say, well, you're a domestic robot. You should stay away from people and maybe ask them to move if they are in the way, but not actually kind of, hurt them in any way or whatever. And you can do like, you can put a whole bunch of low-level conditions like this, like if you're a domestic robot and it's, it's a cooking robot, right? So it has a big knife in its hand and it's, cutting the cucumber. So don't flail your arms if you have a big knife in your hand and people around. Okay. That can be kind of a low-level constraint that the system has to satisfy. Now, some people say, oh, but with LLMs, we can fine-tune them to not do things that are dangerous, but there is always, you can jailbreak them. You can always find prompts where they're going to kind of escape their condition, all the things that we stop them from doing. I agree. That's why I'm saying we shouldn't use LLMs. We should use those objective-driven AI architectures I was talking about earlier, where you have a system that has a world model, can predict the consequences of its action, and can figure out a sequence of actions to accomplish a task, but also is subject to a bunch of constraints that guarantee that whatever action is being pursued and whatever state of the world is being predicted does not endanger anybody or does not have negative side effects. Right. So there, it's by construction, the system is intrinsically safe because it has all those guardrails, and because it obtains its output by optimization, by minimizing the objective of the task and satisfying the constraints of the guardrails, it cannot escape that. It's not a fine tuning, right? It's by construction.